Welcome. Happy St. Patrick's Day. I'm so sorry that I was not able to join you in person. Luckily, my internet appears to be back up again. And at least in the interim, I had my trusty cell phone and carrier. These photographs are actually me at Blarney Castle in Ireland, kissing the Blarney Stone. Down here is a silly picture of me being lowered down to kiss the Blarney Stone, if you're familiar with that. My theory is basically you get the gift of gab if you kiss the Blarney Stone, but I think what's really happening is that they tip you upside down and then you kiss the Blarney Stone, and then you rise back up to your feet and all the blood rushes to your head and you get giddy. And you also get giddy climbing up and down the steps of the castle, and so that's really the effect of the Blarney Stone. Nothing supernatural about it. So happy St. Patrick's Day. I hope it can be happy wherever you are. Today I'd like to talk about some course policies and updates there, and then some discussion about our favorite topic, the coronavirus and the economist's view of that. And by that I mean that the things I've tried to synthesize a little bit by keeping aware of the discourse on Twitter, which is, I think, one of the more useful places to see the economist side of the discussion. You can also, of course, read newspapers. And then a few more words about St. Patrick's Day. Sadly, it's not going to be the day it usually is around the country and around the world, but also the demography side of it, which is fun, and I think you'll see the fun in that. Something about Census 2020, and then on to the course material. So I suspect what I might do is upload two different videos, one that does the first part of this, and then one that does the course material, in case folks don't feel like clicking all the way through. So that might be the way going forward. I'm learning as I go with this, as you probably are as well. There are ways of recording bite-sized material online. That's the state of the science there, that usually smaller videos are thought to be better for reaching audiences, and so I'll try my best to comply with those best practices. We're still working on the midterm. We'll get it graded as soon as we can and get back to you. We reported just one deficient grade among the class of 300 at midterm here, so everybody's in pretty good shape, and we will get back to you with more details as they become known. Lab number 8 is the next lab. It's due on Friday, April 3rd, the first Friday after spring break, so there's a good long time to do it. We are committed to distance learning. If you need to go home, please go, and we will meet you there via the internet, whether it's recorded videos like these and other means, or Zoom, or what have you. If conditions improve, we might provide in-person instruction again. I suspect they won't improve in time for the end of the term, and I'm as disappointed as many of you may be about that. It's been a pleasure. It was a pleasure. It still is a pleasure conducting the class. It obviously is quite a bit different than the way I thought it would be, just like I'm sure it is for you as well. There are no attendance requirements for now, and I don't know if we will be reinstituting them. Stay tuned. I'll let you know if we are. We're reevaluating different content delivery modes, and I'll do the best that I can. We will do the best that we can to help with the changing delivery modes and trying to get them in the format that are best for you. And so I plan to keep reading your feedback and trying to understand how to move forward. We all get cut some slack here. The students definitely get cut slack. Instructors also are adapting to these changing circumstances as fast as we can, and we will get through this. Just as a side note, as you can see behind me, this is actually a changing table. My 14-month-old is still in daycare so far, but our 3.5-year-old is at home with us, and that may be the case for many of you as well, and so it's been a challenge to try to juggle all of this, just put it mildly. So the learning objectives in this part of the course are understanding and being able to operate with income and substitution effects, and then ultimately using those to explain the things that we really care about, the bottom lines, like the trends in women's work, wages, and family over the past 50 to 100 years. Economists talk about income and substitution effects all the time, and that's because we think that relative prices are really important for understanding behavior. It's clearly not the only thing that matters, and what's happening right now with COVID-19 is a good example of that, in the sense that we are all staying at home, and there's no price per se. It turns out it's a misdemeanor if you violate the shelter in place order, but so that is a price of some kind. But there obviously are many things that change behavior, not just prices. But economists believe that prices are important. So income and substitution effects are attached with any change in price, as we'll see, and hopefully with repetition we'll see the magic unfold and we'll understand them in greater detail. The other thing to say about this is that income and substitution effects are also salient for policy changes. And so right now, policymakers and economists are all struggling to understand what the best shape of policy might be, and in particular fiscal policy. Setting taxes and transfers, sending out cash, for example, lowering tax rates, what could be done by the federal government on the fiscal side. So it's doing a lot on the monetary policy side, but also the fiscal policy side is a relevant thing to think about these days. And you'll see income and substitution effects being subtly discussed, certainly by economists more overtly, and also they're a present part of the conversation in other circles. So let me say, I lived through 9/11. Many of you did also. Many of you might have been quite young at that point. And the 2008 Great Recession might be a little bit more commonplace to think about or to have felt. This feels like a mix of both to me. When I was in college, it was a time of great optimism and relaxation. We were enjoying what was called the Great Moderation, the great, reduction in instability, reduction in inflation, reduction in unemployment after a lot of instability in the 70s and 80s. On 9/11, the world felt like it was ending, but it didn't. COVID-19 is similar in the way it makes us feel like everything's coming to a screeching halt, and of course, in many ways, it has. But that it shares in common, I think, with the feeling after 9/11, when a whole bunch of stuff closed for a long, long time, and nobody really knew what in the world was going on. The thing about the coronavirus is that it threatens to take our grandparents from us, and perhaps more importantly, overwhelm healthcare delivery systems so that they don't survive, and potentially other people as well. And that's why we are sheltering in place to try and stop that. The other thing is that population age structure matters a ton, and there's a reason why Italy is front and center. Italy is a very old country. I'm not sure we've talked about it at great lengths in this course, but it really pops out. Japan, Italy. Japan's an interesting case because it is said they have fewer tests happening there, and probably as a result, fewer recorded cases. We will see what ultimately happens. In Italy, the big story is, I think, most definitely the fact that the population is so very, very old, and old populations are having a really tough time with this disease. The big challenge with COVID-19 and why you'll see Twitter economists talking a lot about this is that it's a new kind of shock. It's a demand and a supply shock simultaneously. On the demand side, we typically decompose GDP into its components. On the spending side, to think about this a little bit more concretely, there's consumers and consumption. There's investment spending by businesses typically. Government spending is in there, and also net exports. And of course, the export sector might get hit as well, but probably the big story is that consumers are strongly shifting away from meals away, and things like entertainment and bars and concerts and professional sports and all that. In the short run, they're shifting strongly toward things like meals at home and grocery store purchases that I hope will at some point tail off a little bit. It's a tough landscape out there for getting basic staples sometimes. Businesses also probably aren't investing for obvious reasons. And so there is a side of it here that suggests that either direct government spending or perhaps more likely cash being sent to consumers so that they might be encouraged to spend on necessities might be a way to sort of inject some energy back into the economy on the demand side. The problem is that this is also a supply shock, and the way to think about that is with the central equation that's in the Solow model, which is the Cobb-Douglas production function. If GDP is also produced by capital and labor working with technology in tandem, the question you might ask yourself is what happens when labor declines by a lot because of illness and social distancing? Output is going to fall a lot as well. And it's not too clear what can be done about that with any policy levers at all. The latest, I think, especially on the medical front, is to think about ways of quickly activating healthy labor doing important things like being in the health force, working as nurses or what have you. So the policy responses that we've seen so far are things like this. On Sunday, the Fed cut interest rates to zero, or effectively zero. I mean, there's this other thing that we could talk about, how you kind of sort of can't have a negative interest rate. So what the Fed usually does is target something that's near zero but still a positive rate. This is the right move, but asking whether it will help is a good question. It's hard to tell, and markets have kept falling, but I think perhaps more accurately I should have said that markets keep falling and then rising and then falling and then rising and then falling and then rising, and who knows where that's all going to go. But I think we are in for some chop. Congress and the president appear to be jousting back and forth on the shape of a rescue package, of a fiscal stimulus package. So there's precedent for giving taxpayers cash, so we might see that soon. And it depends. If you filed your own taxes, you might receive some cash in the mail. That happened in 2001, also happened in 2008. It's effective usually, but the questions, of course, to ask are whether that would have the same stimulating effect on the economy today that it did back then, because circumstances are different. Would people spend more? Would Amazon be able to fulfill it? Would they be able to find healthy workers? They probably have the trucks to do it. The issue, of course, is the healthy labor. And, well, the other thing is the workers who are not too frightened to go to work. And I think that might be an emerging issue. Kind of the payroll tax is also being discussed. It's reasonable, not obviously impactful, I would say. And a very clever thought that was out there, but I don't encourage you to do this. You should take care of yourselves during all this. But an example of some clever thinking about policy is that you might buy gift cards to local businesses for later use. It's a very clever way of trying to move funds to places that need it, firms basically, and thus ultimately the employees that the firms hopefully would not be laying off if they could count on later business. If things all blow over in some weeks and months, as they seem like they should, then this kind of thing might be the way through it. But who knows what exactly will come. On to lighter topics. Happy St. Patrick's Day. And the fun thing to talk about here is the very large number of U.S. residents who claim Irish ancestry. In 2011, the number was high. Over 10% of the population, 34.5 million U.S. residents, claimed Irish ancestry. And that's a little below levels in 1980 and 1990 that were reported by Mike Hout and Josh Goldstein. Josh Goldstein usually teaches this course, C175, and they have a paper back in 1994 that looked at this. Still, in 2011, there were 7 Irish Americans for every single resident of Ireland, which had a population of just 4.6 million. That's remarkable. To have that many more Irish Americans or self-identified Irish Americans outside of the country. Now, there was a great exodus, the Great Famine of 1846 to 1847, which was caused by a massive failure of the potato crop, caused a big out-migration. And so the Irish population peaked around 8 million, fell below 6 million. Some of these were deaths, of course, but a lot were Irish people leaving and fleeing the famine. Total immigration to the U.S. between 1790 and 1990 was about 5 million people, most arriving between 1820 and 1920. And as we'll discuss later in the course, that wave of immigrants, just like current waves of immigrants, were not always welcomed with open arms in this country. We've got a long, healthy history of welcoming immigrants, but there have been many times when many of the natives were not so keen on sharing the land with new residents. And that was definitely true about attitudes toward the Irish. It's also true about attitudes toward different waves of immigrants from different locations today. So today there are about 7 times as many Irish Americans as there ever were actual Irish immigrants to the United States. And that comes out of the previous slide, the bottom number. And it turns out that this is much more than would be applied by Irish fertility alone, which wasn't really high. It turns out that there were roughly equal parts Protestant and Catholic, and that was also true for German immigrants. And the mix meant that Irish and Germans had access to more potential mates of the same religion but from different ethnic groups. More intermarriage, more subjective closeness to Ireland resulted in more self-identification. So it's a very fun, clever paper to read in case you're interested. And the basic story is marriage markets, which we're talking about right now, identity, which is a fluid sort of thing. And, let's face it, St. Patrick's Day is a lot of fun in usual years. So identifying yourself with Irish ancestry is a fun thing, too. If more backgrounds were viewed sort of, as just fun, I would imagine you'd see more Americans identifying as being, having fun ancestors. There's always going to be some kind of hook there, I guess. The potato famine event makes for a good exam question, so you might see something like that on the final exam. And you might think about this: what happens when the fruits and vegetables of one's labor fall victim to blight? The idiom there is, of course, the fruit of your labor. And in this case, it's really a vegetable, I guess a legume, right, a potato. And you might wonder, what would neoclassical models like Sullivan and Malthus tell us about what happens to wages when something like that happens? Why might Irish immigration to the United States accelerate after the blight? It doesn't kill people, technically, although a famine could. And then finally, what effects might increased Irish immigration have on the Irish economy and on the U.S. economy? And we're getting to that later in the course. So a few other things about Irish history is that is with many places, not just Ireland, beer is sort of central. It's central in the history. It turns out that one of the big saviors of humanity actually was brewing, because small amounts of alcohol actually make water less dangerous. So standing pools of water would be a little tough. The alcohol tends to kill off a lot of the nasty stuff that lives in water. So there was a fun article some years back, 12 years ago now, I guess, that was titled Guinnessometrics, which is a play on econometrics, and talked about the history of the student t-test, which you're familiar with if you've taken econometrics here at UC Berkeley. William Gossett was master brewer and experimental scientist with Guinness, and he was student in the article that ultimately got published. He did it anonymously. The problem that he was set out to solve is how, with just small samples of malt or hops, you needed to try to figure out the quality of the rest, and thus of the beer shipped around the world. You could figure out quality of malt or hops by testing it, but the problem is that you'd end up destroying the sample. So you don't want to test that much of it. And thus, students' tea developed from this need to try to figure out, if you just took a random sample of something, what were the boundaries on what you could expect to see in this population of malt or hops. So cool stuff, fun stuff. Here's another look at Irish demographic history, which is pretty interesting. We've got the total dependency ratio in blue, the youth dependency ratio in yellow, and the old age dependency ratio in green down at the bottom. Some change in that up to 2014, but the big action here was definitely in the youth dependency. Along the bottom too, I've got some boxes that indicate at the left-hand side of both of these boxes the timing of contraceptives becoming available without prescription, and contraceptives becoming available to everybody aged 18 and over. Ireland, of course, predominantly Catholic. Kind of an interesting point. Well, Northern Ireland is predominantly Protestant, and that has led to some challenges historically. But traditionally, Catholic countries not so big on the contraceptives, and these developments then set into motion a big reduction in fertility, and at the same time, but also hastening it. This is the demographic dividend. Log real GDP per capita rising rather strongly before tailing off a little bit. This was the Great Recession that we were talking about a little while ago, this dip here toward the end. So the other thing that dovetails in here is that Census 2020 is still happening. I hope it will actually work. Obviously, it's not top of mind for anybody, and that's kind of the problem right now. So I received an invitation letter in the mail, and it was to participate online. I haven't filled it out yet. I hope to, but obviously this week has been a little bit busy. all races get to fill in their origin. And this, it's a funny way of phrasing it, really, because we're all members of the human race, of course. But you can choose things like white or African American or black. You can also choose Asian American and other racial identities like that. But you also get to fill in an origin box. So a question to ask is, how many white non-Hispanics will state Irish as their origin this time around? And I think it's new that this is there for everybody. I believe we took a look at that in earlier classes. Many other interesting questions, too, about how folks with ethnic identities will self-identify. One of the big questions before the thing was finalized was whether or not to include separate boxes for people who typically identify as Caucasian, but who may hail from areas like Persia, modern Iran, or Armenia, or other parts that are traditionally known as Caucasian, but have a fairly distinct identity from other places where people who self-identify as white originate from. And this is, of course, true in other zones and other racial identity groups as well. Hopefully we'll get the data collected somehow. Census workers probably won't be going door to door anytime soon, and normally they would have been doing that starting, I think, fairly soon. But needless to say, I don't think anybody's thinking about that. So back to course material now. What we're going to do is think about modeling female labor supply, and we're going to jump from this then to modeling fertility choice, because the two things are related. Here we're going to begin with a household that has a man and a woman, so it's a particular type of household, and one would maybe think of it as being a stereotypical 1960s household if you want to place it in some historical context. The man works maximal effort, does no housework, and earns an income uppercase Y. The woman faces a market wage W per unit of time, can trade some portion of her total time T for market wages. The time the woman does not spend working is leisure or home production. The critical thing here is that this other use of time needs to have value in and of itself. That's why traditionally in labor economics, this is just a standard model out of labor, it's usually referred to as leisure, and we all enjoy our leisure time. I know I certainly do, even though I have so little of it these days. So it needs to have value. If you think of it as home production, that's a more obvious thing here. But one can get tied up in the problems that this raises, because it's not clear that housework is fun. I don't think it is. I actually do a lot of the housework myself here in my household, and I don't find it very fun. So it's perhaps easier to think of it as leisure, because leisure is clearly a good thing to have. The labor supplied by the woman is T minus H. She's got total time uppercase T, so T minus H is the time supplied by the woman to the formal labor market. And the rest then goes into leisure or home production, whatever you want to think of it. It's H is the other side of it all. The earnings that she brings in there are W times T minus H, and total household income is uppercase Y plus the earnings, W times T minus H, and that equals total consumption. So the goods here then are total consumption, which you have to pay for out of your income, your total income, and the other variable here, which is it's H, it's either, if you like leisure, it's a little bit more obvious to think of that as a good thing, or it could be home production. Now, what this looks like is a budget constraint with a kink, where the kink is at this height, uppercase Y. It's the amount of cash that the husband just brings in regardless. So if the household locates itself out here at this variable here, which is home production, H equal to T, that means that they can afford that because they're bringing in, the husband is always bringing in this income uppercase Y, so that's why there's this kink here. With indifference curves, like we talked about last time, we'd seen some kind of tangency in the interior. It could also occur here at the kink. Looking at it, it's pretty obvious it's not going to occur here on this vertical part. You would have to draw a pretty strange indifference curve to get some kind of a tangency over here. So it's good. You're going to see a tangency somewhere here. It also could potentially occur way up here if preferences were such. So to begin, we're going to describe what's called a pure income effect. Suppose there were an increase in the man's earnings. This just shifts the budget constraint upward without changing the slope, since uppercase Y is the only thing that changes. And here I've got some animations that show that. It would just look like this, where now the gray line is the old budget constraint line. This is a pure income effect for rather obvious reasons. With more income, you can buy more of everything. Here you've got two goods. We pretty much always do in two dimensions. You've got this one going that way and this one going vertically. So two goods there, and you buy more of both. So more home production, H double star, that rises with the pure income effect. It has to. A pure income effect also on C, that's total household consumption. So C star rises up to C double star. Now, is this realistic? It's problematic if you assume that H is actually home production. If H is leisure, it's pretty obvious that we like it. If it's home production, it's not all that clear. So if you like, you can call it leisure. I switched to calling it home production here in the slides just because it's more consistent with where we're going to take it next, which is transforming it into the number of children, which obviously has this relationship with working at home, because you have to wash their clothes and all this stuff. It's another thing that's useful in the household, but you have to spend time doing. Now, we saw what happened if there were an increase in the man's wage, the person who just works and doesn't have any role in kind of the direct choice variable here. Behind the scenes, the idea is that both members of the household choose what's happening. One just has apparently no preference or no ability to appreciate leisure or home production. The woman's wage shows up in a different part of the budget constraint, though. It's going to be the slope, and nothing else affects the slope other than the woman's wage. So when the woman's wage rises, the budget constraint pivots upward. So we're on this gray budget constraint now, and the thing will pivot in a clockwise fashion. There's a new optimality point, but where is it in relation to the old? And so here's going to be the problem. We'll have income and substitution effects working in different directions on home production, on the horizontal good, and in the same direction at least on total household consumption. And that's good, but there's indeterminacy with what happens to home production. So I've drawn it in this way, but we need to be able to decompose this change into income and substitution effects to understand the relative strengths of these two things that are both there, and it depends a lot on the complementarity between these two goods. If the indifference curves they look like L's, then you're going to see some result that allows for no substitutability between these things, basically. If they are very gently sloped, there's a lot of substitutability. You'll see a lot of switching if the price changes, a lot of substitution. So the way I've drawn it, we could pick out what happens to both of these things. So H triple star is to the left of H star, meaning that work has increased. Home production has fallen. That's what we're indexing here. So work, which is the distance between this blue line and the optimal level here, that's work, and that has increased. So that's the way I've drawn it, but there are these different components going on here. So we see a big substitution effect away from home production, this other good, toward household consumption, because the price of household consumption has fallen, the wage has risen. So there are income and substitution effects here. And the question is, how do we decompose these? And here's what we're going to do. We're going to think about a change in this relative price of home production, and that's determined by the wage. And what we're going to do is think about holding utility constant. What does a change in this relative price imply about the optimal choice? So I'm trying to get the slope right here from your perspective. What happens when this thing becomes steeper? And the answer is it's a sliding around in a northwest direction on the indifference curve in this kind of way. So I've drawn in a new budget constraint that's parallel to the one we end up on, but it's dashed. It's a figurative, or just there to for kicks to kind of help us understand what's going on here. And the pivoting along in this way, following the slope of the indifference curve, that's going to be the substitution effect. So there I've drawn it in teal, starting from H star up to this figurative point HS. That's the substitution effect. That's where we would have gone if miraculously the change in price were just offset with income transfers and things like that, so we stayed on the same level of well-being, of utility. What's left over then has to be the income effect. And it looks consistent with what we saw earlier when the man's wage changes. An income effect is just a parallel shift of the budget constraint, keeping the prices the same. Okay, what else to say here? The two arrows we've got going this way and that way, notice that they're both pushing us up in the graph. But notice, however, that they're not pushing us in the same direction horizontally. So the teal one is pushing us in one direction, that way, and the green one is pushing us in another direction that way. I hope I've gotten this correct for you guys watching this. I'll see whether the video is switched or not. I may be getting it wrong. The point is that the two arrows are going, they've got this dimension that's at odds there in terms of the home production variable. And that's unfortunate. It means that the net result is theoretically indeterminate. You have to think about the strength of substitution, basically. How much are these two things substitutes versus complements? And that depends on how you draw the indifference curves or what kind of mathematical function you set up, for example, to determine well-being. So this is the name of the game. We're going to keep doing this, decomposing into income and substitution effects, trying to ascertain when it is, then you can tell they move in the same direction. Here, they move in the same direction of consumption. Both of these things push you upward in terms of the vertical variable here, the total household consumption, but they push you in different directions in terms of the horizontal variable in this case. And that's not always true. It is in this example. So again, to reiterate here, in the case of H, that's the horizontal variable, you can't be sure which way we've gone since the income and substitution effects are operating in different directions. You've got the two arrows that are pointing in different horizontal directions. The way I've drawn it here, there's a lot of substitution and that outweighs the income effect and leisure falls. So there's a switch toward consumption paid for because of increased working by the woman. For consumption, in this case, income and substitution effects operate in the same direction toward an increase. Now, what if the woman is not working, but her wage rises? In many societies during early stages of industrialization, women are not working in the labor market. That is, they're located at this kink down here. At that point, an increase in the female wage is said to have only a substitution effect on leisure, which increases work. Part of the way you can see that, or understand it intuitively, is that at this point, when the woman is located here, she's not working, she's totally out of the labor market because the wage is way too low, it just doesn't pay. At that point, a change in the wage will not have an income effect because she's not earning any income from working. That's a way that you can make this intuitive. You have basically a pure substitution effect, at least at first, when there's a rise in the woman's wage at this stage. That's what we'll see in the literature, and it's useful to internalize that. A rise in the woman's wage, generally speaking, has an income and a substitution effect, and you don't know which one will win out. The substitution effect pushes her toward working because consumption becomes cheaper, relatively speaking. In other words, your opportunity cost, if you like, of staying at home and not working is higher because your wage is higher. But it also has an income effect. So if you have a higher wage, you've got more income, and you might choose to work less in this model. So that's the typical indeterminacy. Here, if the woman's totally out of the labor market, you only get a substitution effect on leisure. If you diagram it out, it will look something like this. It's pretty clear to see that you've got to have some sort of tendency that's in this direction, right? So she's got to start working. The problem is that if you were to decompose it, you will see that there is actually a decomposable income effect here, and that's true. So this is not a gotcha question that I would write on an exam, right? There's the substitution effect. It's enormous. Here, technically, also is an income effect, and it is there because it's a discrete jump. It's not a tiny little increase in the wage, which would basically get you just a movement along the indifference curve there. True, but so both of these are important to be able to do. To decompose this into the substitution effect and the income effect, that's important. And also to internalize that starting from not being in the labor market, there is no income effect. There can't be. She's not working. She's not bringing in any income. Here too, notice that a rise in the wage has these two effects. They are countervailing in the case of home production. They're moving against each other here for this horizontal variable. They're moving with each other if you look at total household consumption. It's obviously good for total household consumption for living standards, if you like. It's not obviously going to increase the woman's work here with these two potentially offsetting effects. The way we've drawn them, of course, and starting from where we were, you have to have an increase in work from zero. And it's because work was at zero to begin with. So to recap what we found, increases in male wages should probably be associated with decreased female labor supply, other things equal. And there's a whole bunch of fascinating literature that shows this kind of thing typically is empirically real. It, of course, requires that the couple, the dyad, be sort of traditional in some sense, that the male doesn't trade off into doing housework or something else. Typically, although not exclusively, one will see that men kind of basically work and they don't do anything else. So it's not an unrealistic thing to expect to see this in the data, and typically you do. I believe during the fracking boom in North Dakota, this kind of thing was happening. That increases in male wages typically decreased female labor supply. And of course, the next step in this is to think about what the effect is on fertility. And I think it is associated with an increase in fertility too. Increases in female wages could either increase or decrease work depending on whether the substitution effect dominates the income effect. So ultimately, the effect of female wages on female labor supply is an empirical question. And why would it matter what the answer is? Well, there are real-world policies that work in this sandbox. The Earned Income Tax Credit is a transfer to working parents with kids that operates like a wage subsidy. The more you work, the more that you earn, of course, but then in addition to that, the Earned Income Tax Credit subsidizes your wage further. The question, of course, is whose wage? And if a mom is married, she's already seeing an increase in household income from her husband, and the EITC may effectively subsidize her staying at home. That's not necessarily a bad thing, but the way we think about this in the model is that, well, there's probably an effect on her wage in addition to the stimulating effect on the husband's wage, and the husband's wage will exert a pure income effect on her labor supply, which would reduce it. Other things equal, it would increase her home production or her leisure. Complementarity matters. We talked about this last time, but having some curvature to these indifference curves is important. So if the household views these two things as very strong complements, then you're not going to see a substitution effect. There's just an income effect. That's all there is. So if you were to draw these on an exam, you need to pay attention to how you draw the indifference curves. If they end up looking like L's, you're saying that they don't have a lot of substitutability between these things. They're strong complements, and you don't end up getting much of a substitution effect, just a pure income effect. If instead you've got strong substitutes, you might see a story kind of like this, where the indifference curves are very gently sloping. What happens? You would see a very, very strong substitution effect. What happens? You decide. The classic. I need a laugh track for these sorts of things, but that was always, what I saw when watching TV as a kid. Whenever you get out your action figures, which are definitely not dolls, right? You decide. Well, the answer is it's a big substitution effect. So the takeaways are the following. When a price changes, there are almost always income substitution effects on the demands for two different types of goods. And so let's think about a price P1 of good X1. For X1, these two effects of own price changes tend to stack or operate together or amplify. For X2, these two effects of opposite price are countervailing. And so how big the substitution effect is depends on complementarity. How do we know the degree of complementarity? In C175, assume some medium amount. In the real world, measure it. What do we see during the course of development? Prior to industrialization, women and men both engaged in a lot of household production. You could think about agrarian families in farms, for example. Industrialization typically raises male wages first. And you might wonder why. There are several reasons. The labor might be more physically demanding when factories open. It's perhaps not things to begin with that are very easy physically to do. It could be working in this factory producing coal or steel or something. There may also be social stigma. That's a big part of things. And the labor may require certain skills that only men have acquired at this early stage of development. So what do you think might happen then to female labor force participation at the beginning of industrialization? It might fall because of the income effect deriving from male wages that actually push women out of work at first. Over time, female wages ultimately tend to rise during industrialization. You might then wonder, what does that typically do to female labor force participation? And it probably rises when female wages rise. Technically, the reason for this is that we think the substitution effect would dominate the income effect for women because they're pushed out all the way during the early course of industrialization, pushed out of the labor market usually by the strong income effect of male wages. So what kind of shape would you expect to see if you looked at female labor force participation on the vertical axis against time or income along the x-axis? Would it be a straight line or something else? Typically a U-shape, a reduction first in participation during development as male wages increase and social norms may have yet to evolve. And then as female wages and education increase, participation increases. And it turns out that that's what we see. So what this is technically a grouping of a bunch of countries measured in their GDP per capita, their average GDP. The different trajectories here are the snapshots in different years. So 1970 then is this collection of countries measured in their GDP per capita along the horizontal axis. And then their female labor force participation rate. Technically, it's women not of childbearing age, so that's another thing that might be important here, obviously, as we're about to get to. So each of these countries then that are underneath the lines, they're actually data points here, form a U-shape, and it seems remarkably consistent that countries as they develop and they raise their GDP, they're headed down the ski slope here, down to the bottom of the valley, and then they head back up again along the gondola, back up here to maybe go down another slope. I don't know, but it probably just keeps rising. We'll, of course, have a look at this in a second. So we're going to look at the United States. In developed countries, generally speaking, you might see some different stories. And we're going to talk a little bit about what Claudia Goldin, the great Harvard economist, has to say about this in a paper from 14 years ago, From the Valley to the Summit, the Quiet Revolution that transformed women's work. I guess we just saw that, didn't we, on the previous slide? The valley up to the summit. That's what we're talking about. We see very big changes in labor market expectations, college graduation rates, professional degrees, labor force participation rates, and the age at first marriage. This and several slides forward show us the changing expectations here of employment and then later of different things of female youth here with different age groups and at different points in time. So she's looking at this critical period of the 1960s and the 1970s when there was a lot of action in these sorts of things, which is not to imply that there isn't still action. It's just that we see kind of a monotonic change here over time. All of these age groups, they're not, of course, that different in age, but all of these age groups strongly increasing their expectation to be employed at age 35 over time. This is a fun, longer time series showing college attendance rates, college graduation rates, and the vertical axis here is actually the female rate minus the male rate. So a negative number means that the male rate is larger than the female rate, and that's what was happening with parity roughly in college attendance and college graduation, which of course back in this era, so UC Berkeley was founded in 1879, I think, 150 years of life. 1869 it must be, right? I'm trying to do my math in my head there. 150 years, 1868. What year is it? I don't know. I'll have to look that up. So UC Berkeley was founded around here. One of the remarkable things was, I believe it was always coeducational. That was not always the case. On the East Coast in particular, and this still persists to this day, that there sometimes are colleges for women and colleges for men, and they are not the same. College attendance and college graduation, though, were for a few privileged select families for many, many years, and that was certainly true in the 19th century. And then a big change began to happen, which actually pushed female attendance and graduation rates below male rates. Male rates were basically increasing, I think, as broader social change came at first, and then a big, big rebound starting after World War II, where now we're in this era where there's a significantly higher rate of college attendance and a higher rate of college graduation among women than among men. I guess I should point out in the previous slide, this is actually birth year, which is different from chronological year, but we're talking about a difference of 20 years or so. Median age at first marriage rose for everyone. So this is showing, I think, men and women combined, I think, but here we're looking at, I would have to check the source again. You would think probably this is women, actually. But I think similar trends were true for both men and women. So the point of this graph is to show that for the folks with some college attendance and also those with a college degree, those college graduates, and so they're higher here in terms of the age at first marriage, and for obvious reasons. If you're staying in college for an additional 2 years, you might get some effect, like it appears here, like an increase in about 2 years in the age at first marriage. You get married when you're done with college. You could get married in college, of course, but that's part of this is sort of a mechanical thing. Both of these groups were trending strongly higher. Later marriage, not earlier, with some dips and peaks. And again, birth year technically is the thing here along the horizontal axis, not chronological year. So the next slide I'm going to show you is out of that same paper by the great Claudia Golden. And it also shows your own self-reported importance of certain life goals. And this was measured back on February 11th. And we talked about 3 different life goals here: obtaining recognition from colleagues for contributions to my special field. We talked about raising a family and also being very well off financially. And I asked you to rate these on a 4-point scale as essential, very important, somewhat important, or not important. So Golden looks at how this shows up in the data by taking the folks who say either essential or very important and giving them a 100%, and then taking the other folks who rated it lower and giving them a 0, and looking at the average number that you get then with that kind of scoring, and then measuring the difference between males and what they say and females. And what you get is something that looks like this, where the male minus female weight then is a percentage point difference in who is saying the highest of the 2 rankings here. And you see a big convergence in this. So at the beginning of the period, a big male disadvantage, if you like, with ranking family as being important, and then a convergence up to female levels. A big difference here in the percent of women who ranked financial success high relative to men, and then a big convergence. Still some divergence here, and then a similar story with a greater sense of sort of level convergence here, right? So we're starting higher. The males valued this more, recognition by colleagues, and then sort of a convergence here. So I've measured this now 3 times. So in the spring 2015 class, this is what you saw. So the little triangles here are family, and it was ranked way down here, implying among this spring 2015 class, 5 years ago now, implying that men on average in that class didn't rank it very high compared to women. But also these 2 things were also lower, that men didn't rank that very high either. Here the circles are recognition by colleagues, and those are the light circles, and the dark circles are financial success. So it's fun. I don't think I would generalize much from what these various classes have done. So here's the story with 2016. It's all much more bunched together. But it's still kind of off the chart low, if you like. I think what's as revealing is the students who take Econ 175 are probably not the average student that is measured in the survey data underneath this graph that Claudia Golden generated here. And finally, these are our data, and they're different yet again. So it's kind of fun to look at these 3. All these classes are really quite different, and we seem to be here where how to read this. Well, so recognition by colleagues, I guess men in the class placed a greater weight on that than women. Family is equal. That was interesting. Financial success, men actually placed less of a weight on that than women did in the class. So that's the circle one here. So it's fun. People have these opinions and feelings, and arguably they're important for where they end up in life. And you can ask people, and they tell you things. And seeing trends like this, it reveals something pretty important about where we have been and where we are now. Well, why did these trends occur in the 1960s and 1970s? It was a mix of a variety of things. And so Claudia Golden goes into this in greater detail, and I won't talk about much of it here, but it's Title IX, it's anti-discrimination, it's social change, it's family planning, it's the availability of the contraceptive pill, partially legalized abortion. We can't say much about the relative strength of these sorts of things. It's very hard to disentangle them, but one that is more easily disentangleable is the contraceptive pill, because of the sharp dates of the availability of it. And it gave women more direct control over childbearing, facilitating later marriage, more focus on careers. And Claudia Golden writes about that if that's useful to you to have a look at. It's a great read, a really cool article. But of course, by recommending any one of Claudia Golden's articles over any other is kind of silly. She's fantastic. All of her articles are very, very interesting. We'll talk about another one coming up soon. Have we reached a limit, or women just having kids later? So this was a graph I think we looked at last time too. It's labor force participation for among 33 to 37-year-old married college graduate women, and then the fraction of children. So these are measured on 2 different axes here, where they had been moving in very different directions. And then suddenly the things started turning around and moving in the same direction after about 1980 with a little bit of a dip. Maybe we've reached a limit at this point. It's hard to raise your labor force participation a ton higher than that, and men have actually seen theirs decline. Interesting stuff. Moving on, now we'll look at a model of female labor supply and childbearing. And so this is going to be the value of time model. It draws off of this work that we just did, developing the story about female labor force participation based on the wage. The difference is going to be that in addition to receiving the wage when working, the mom forgoes spending time on children if she has to work. And so there's a time cost and a money cost of children. Both of these things would trigger income and substitution effects. And the subtle point there is that you have to spend time raising the children. And so if the time cost effectively rises because of some external reason, or if the way that you get A more educated child, for example, is spending more time invested with the child. That's salient then for labor supply decisions. At the end of the slides, of course, we'll see what a lot of people do these days, which is hire help, whether it's daycare or nannies when they're a little bit older, preschool, and of course, public school, after school programs, and things like that. Needless to say, you still have to spend a lot of time with your children. Many of us are finding that out, of course, especially this week when suddenly we are spending much more time with our children beyond even the after school hours, but the during school hours as best we can. Children cost time. That's the subtle part. That's part of what's called the shadow price of children, or the total price, the part that the market sees, which is the money price, but also the time cost translated through the price of time, which is the wage. So it's basically the same as the model of labor supply we've already seen, except children, not leisure, is the other good, or are the other goods, if I conjugate the verb correctly maybe, and children cost time and money. So we'll assume each household has a full-time worker and a flex worker, and the full-timer you could think of as the husband if you like. It's equivalent. It doesn't really matter a ton what your semantics are here. Full-timer works maximum effort, does no housework, earning a market income Y. That looks very familiar from the model we just saw. It's going to be just the exact same shape. The flex worker faces a market wage W per unit of time and can trade some portion of her total time or his total time or their total time T for market wages. Now, the difference is going to be here that the slope of the budget constraint is not just the market wage. It's also the time spent raising children translated through the wage. And we'll see how that works in a second. So the time spent not working is spent raising children, and you get these children, which are the goods here in the model. And we're going to index them with this variable n, and you can have non-integer children, which of course is silly, but we're not going to worry about some kind of step function weirdness. Just try to ignore the fact that you can have 0.1 child, even for a TFR that makes sense, but for a kid, obviously a tenth of a child doesn't really make a lot of sense. Children cost time and money, and they're going to be kid time costs little t. That's multiplied by the number of children, then gives you total kid time cost of little n times little t. Each kid also consumes Q goods at price P. And this then is going to be our entry into the quality quantity discussion for next time, that Q is also an index of quality, if you like. It's the number of goods required to be spent on children, and you could think about this as the number of years of education that are purchased, at college or something like that. There's then parental consumption also, which is another good, and we're just going to normalize the price equal to 1 for simplicity. We're going to call this X, which is a bit unfortunate. Part of that's because there's a Y that's up here. The reason it's unfortunate is that this is going to be the vertical variable. So try not to let that screw you up. It's easy to get confused. We'll assume that the household runs out of time before it runs out of money, and thus there is a kink in the budget constraint, just like we saw in the labor supply model. A man's income can fully, or the full-time worker's income can fully cover maximum children costs. So like before, there will be a budget constraint in preferences. We'll assume that kids are good, and more kids are more good, but with a diminishing marginal utility, just like with leisure or with some other type of good. Here again is the confusing part. X is the vertical variable. Hopefully, as economists, we're used to seeing, prices along the vertical axis, which are, and quantities along the horizontal, which is already sort of maybe topsy-turvy a bit. Coming along for the wild ride here, it does get a bit confusing. If you're confused, try to ask a question. So the axes are total consumption. That's going to be income minus spending on kids. That's the vertical axis, and the number of kids over here. The budget constraint will look similar, but it is constructed a bit differently, and this will be probably a little confusing. There's going to be a linear trade-off because we've assumed that the time cost and the money price of kids are both linear, and so is the mom's wage. What are the constraints? Well, mom's work effort is her total time minus the total kid time cost. So it's uppercase T, that's her total time, minus little n, that's the number of kids, times little t, the per kid time cost. And so the mom's income then is the work effort, so total time minus the time spent raising children, quantity times little w, that's her wage. The dad just works and earns y as income. So money expenditures are on parental consumption, that's x, so that goes on the right hand side here, and then also money expenditures on children's consumption. Here's the number of children times the if you like, the quality units Q. It's, for example, the number of years of college or something like that, or the number of pairs of pants, or kids grow out of pants so quickly, it's hilarious. And then here's also a price of children's goods that we're going to use for comparative statics. So the budget constraint, it sets equal the money income, that's on the left-hand side, to the expenditures, the money expenditures on the right-hand side. Total consumption with price normalized equal to 1, so that just clears everything up. And then this is the spending on children, the money spending on children. Of course, implicit in here is going to be the time opportunity cost, so translated into money also via the wage, but there's this opportunity cost part, and that's going to be part of the total or shadow price of children. To graph the budget constraint, what you need to do is solve for x. So here's just the same math from before, and now rearranging. Solving for x is pretty easy. You subtract NQP from the right-hand side, flip everything over, here it is, and now you might want to collect coefficients on n and collect your terms. So here's an n, here's another n, and together then you'll see this kind of thing with a minus sign in front of it. So here's a uppercase Y plus W times uppercase T. That's, if you like, sort of the endowment, National Endowment for the Arts. It's the full-time worker's income, and what would happen if there was no time spent on children. If n is equal to 0, you get this, and you get to spend it all on x, your consumption. And here then is this shadow price of children, which is the opportunity cost of not earning the wage, translated by the time cost per child, which could be different. And then it's summed with the actual financial price then of child goods. So it's a downward sloping line in this xn space because all of these variables, q, p, w, and t, are all positive, and there's a negative sign in front of it. So it's a downward sloping line. This thing in the red box is the total or shadow price per child. The actual money price of one child's consumption is Q times P, and the foregone wages or the opportunity cost of having one child is W times T. That's the per child time cost. And so the sum of the overt and implicit prices is what's called the total or shadow price, and that's what's showing up here in the red box. The intercept term is the sum of dad's income and mom's total potential income. The budget constraint looks exactly the same as before, and there's a kink. The difference is that the slope rather is more than just the wage. Here is the max number of children you could possibly have. If you maxed it out, you would be splitting your total time uppercase T across these nmax kids at rate little t. So if you might think about multiplying both sides of this little equation here, n max equals big T over little t, multiplying both sides by little t, and you'll see that that's why this is true, that n max times little t is all of your time spent on children at rate little t per child. The the vertical axis intercept is the same. It's uppercase Y plus W, little w times uppercase T. It's what you get if you don't have any children. The slope is different and more complicated. It's not just the wage or the money price of kids, it's both. It's the full or the shadow price of children. So looks exactly the same. The difference is that the slope is a little different, and there are these other pieces there. It will still react in many familiar ways, so a rise in the woman's wage still produces this same kind of story about a pivoting. So there's an optimal spot. The height of the kink is sort of a funny one. It's the cash left on hand for parental consumption after you've exhausted all of your time. So the total kid costs at this point would be n max. It's big T over little t times Q times P. That's total kid costs at that point. And so parental consumption then has to be equal to uppercase Y, what you end up with regardless, minus this amount you're spending on children. So that's a little bit more complicated too. It's not just uppercase Y, you're also spending out of pocket. You have uppercase Y coming in, but then you have a bunch of cash going out because you've got children equal to n max, big T over little t times Q times P. A classic use of this model is in explaining how fertility is typically higher in rural areas. And so this is true over time within a country, say over the demographic transition, which usually lines up with industrialization. Why might you see lower urban fertility? How do you think of the price of children's consumption as varying across space? Well, you have to pay for space to sleep. And it's pretty easy to see this, I think, given where we live, that a bedroom in San Francisco is much pricier than one in Walnut Creek, and much pricier there probably than further out. Maybe Antioch might be further out than that. Another perspective is that the net price of kids' consumption, which maybe factors in their contribution to household production, is high on farms. The net price is low on farms and high in cities. I've misworded this a bit because the household production contribution is high on farms. I'm sorry. The commas kind of make it correct, but I didn't say it right. The net price of kids is lower on farms because they are bringing production to the table. So the net price that the household needs to pay is less. They're actually productive on farms. In cities, they can't do a ton except for go to school. Maybe urban kids, of course, require education to be productive. We'll talk more about that next time. So what does an increase in little p look like in our model? Well, let's think about the reverse of this. So maybe p is lower for this family. We're thinking about the story in reverse, or a move from the country to the city. Where does p appear? It's in the slope here, and it's also in the height of the kink, but is not over here in the vertical intercept. So a decrease in the price of kids P flattens the slope and raises the kink. And so the effect of this then is a counterclockwise pivoting of the budget constraint, which will have income and substitution effects here. And what's nice, I suppose, is that in this case, and so again, we're imagining a move from the city out to the country, so P is falling. It's cheaper to raise your kids. The other natural thing to think about here, of course, is that a lot of times families are choosing their fertility first and then they choose where to live. Doesn't always work out that way, but this would get you to the same kind of logical conclusion that you might move to the country because it's cheaper to live out there and you can afford to have more kids. Okay, that's totally the point here. The income and substitution effects then are interesting because they work in the same direction for kids. So we're finding this flattening here. So the budget constraint pivots counterclockwise. It becomes flatter, and that moves you in this direction toward Florida, toward the southeast in this diagram, toward more children. And we'll see that here. So that's our new optimal point. I've drawn it that way, so it has to be that way, right? Well, okay, but let's think a little bit about what's pushing what in which direction. So maybe you think the answer is clear. It's sort of logical here, but the substitution effect is pushing us toward kids and away from parental consumption, and the income effect increases both n and x because anybody with kids has more real income. This is a typo, if p is lower, the little p, the price of kids. And so that's what we're going to see. Here's our breakdown of it. So suppose we think about the original gray budget constraint and now the new blue budget constraint. Now let's take a figurative or imaginary budget constraint that has the same slope as the new one. We'll put it here in dashed blue. And imagine finding a spot on the original indifference curve, U0, that is tangent to it. where would it be in relation to where we started? It would be in a place like this. So an increase in the number of kids from n-star to this figurative spot in prime, that's the substitution effect. So we're moving in the direction of more kids, reduced parental consumption because we're substituting away from it towards children. And then an income effect that moves us upward in both directions, or upward and outward if you like. The net effect though is unambiguously toward more children when the price of children, little p, is lower. So that's an example of the things moving unambiguously for the number of kids. It's not always the case that there's ambiguity for the number of kids or the horizontal variable rather. What if the husband's wages increased in this model? It's useful to kind of stop and think a little bit about what's happening here. We've got the husband's wages or earnings, uppercase Y, showing up in a couple of places. Just like before, we're going to just see a level shift. Both the height of the kink and the intercept are just linearly dependent on uppercase Y. So there's no effect on the slope. It's a pure income effect for obvious reasons. With more income, you can buy more of each good, more consumption, more children at the same time. Okay, well, here's one of my favorites. This is one way to model daycare or nannies. And how do we think about this? So suppose you could hire as many nannies as you need for as many children as you want to have at a wage, W prime, that is less than the wage that the mother is facing in the market. So you could always gain by hiring a nanny or I guess manny. I don't mean to be gendered in my use of the word nanny here. Hire a helper. Maybe that's a better term to use here. What would you see happening here? Well, if you saw a market wage for hired help that was always below the wage that the member of the household could make in the market, it would never make sense then for the flex worker to spend any time on kids. And the new budget constraint then would hit the old intercept because, so that part hasn't changed. The point is that we've gotten access to this new technology of child help, and we would see a more gradually sloped, a flatter trajectory of the new budget constraint coming out like this, all the way down, to this new intercept n prime max. And so the way to think about this is, you could, in principle, end up way the heck down here. You're like, Geraldo Rivera or something. You got like 20 kids or whatever it is that he's got. He's a very wealthy person, and his partners, I think he's been married and divorced a ton of times, but I think in each case that partner probably has a very high market wage, and that would be the story here. What would you expect to see in terms of the effect on fertility? Can you eyeball it here? There's going to be an income and a substitution effect. And the income effect probably is rather obvious, that if you have this new technology, that's going to be good and allows you to consume more of everything, which is going to be spending more on parental consumption and more on kids. In addition, so the slope of this thing has gotten flatter, and that's going to spur some substitution toward more children and away from parental consumption. So they work against each other. These two effects work against each other for parental consumption. I've drawn a dominating income effect here. But what we would see is this kind of story. It's hard to pick all this out. Maybe if you look at the slide, it'll be a little bit clearer. But drawing the figurative budget constraint, the dashed blue line, it's parallel to this one here, the new budget constraint that's flatter. And so we're finding a point of tangency along the originally indifference curve. It means that we're sliding toward the southeast, toward Florida along U0. That's the substitution effect. We'd end up at a spot like right here. It's so tiny it's hard to see it all. There's the substitution effect. Here's the income effect. It pushes us out this way. So hired help makes you, definitely makes you better off, right? And it also probably incentivizes having more children, increases fertility if you're able to do this kind of division of labor. should say, farming it out, right, to hire help. And then, of course, the funny thing is, you can imagine, well, you could have a fun exam question: what happens when all of this comes crumbling down, when we're all ordered to shelter in place? And the answer is much lower utility in the short run. So we'll see that later. Okay, next time, and this has been a very long video. I think I'll cut it all up to make it a little bit more digestible. We'll see Gary Becker, the quantity and quality of children. And of course, what we mean by quality is not really the traditional sense there. All children have quality. All children are valuable. But parents can and do choose to invest more time and more money into each child, or they can choose not to. There are costs and benefits to things. And so the question is, what do parents choose, especially when the prices of quality inputs were to be rising, and they have been rather strongly over the last decades. Thank you. Hope to see you again soon.